In this video, I will go over a few questions on the final exam practice. The first one here is to use the technology to find the p-value of the following values of the test statistic t given the sample size n and also the alternative hypothesis h1. We are given the mean to be bigger than the mu naught, the assumed value. So the arrow here is pointing to the right, so we know that this is the right tail test. Now if you can draw the curve, we know that the center, this is the t distribution because this is the t statistic. So the center has the value of 0. And your t test here is around 1.212. And we know that this is the right tail test because it's pointing to the right. So here we are looking for the p-value, or the p-value is just the area of this portion. And we can apply the functions on the TI-84 second distribution. This is the t-test, so we go with the t-CDF. Now we are looking for the right portion, the right area here. So the lower bound we start from 1.212, and the upper bound we go all the way to the right. So I'm just placing a very huge positive value, so 9999999, and the degree of freedom is n minus 1. So in this case n is 6, so 6 minus 1, 6 minus 1. In this case 6 minus 1, or 5, and then that should give you 0.1398. So that's the p-value. 0.1398 is your p-value, or the area under this curve right here, and that should be the answer A. This is the next question. So they give you a test of the H0, the null hypothesis mean to be 59, versus the alternative hypothesis mean is different than 59, is performed using a significant level of alpha equals 0.01. So we know that H0 is mean equal 59, where H1 is when your mean is different than 59 and your significant level alpha is 0.01. The p-value here is also given for you. So the p-value here is 0.115. Now they ask you if the true value of the mean is 59, does the conclusion result in a type 1 error, type 2 error, or correct decisions? Now recall that type 1 error. What is type 1 error? Type 1 error is when we reject the null hypothesis when it is true. And type 2 error is when we fail to reject H0 when it is false. So type 1 and type 2 error. This is what we learned before. Now we got the p-value is 0.115, and the p-value is greater than alpha. Alpha is only 0.01, right? 0.115 is bigger than 0.01. And anytime when the p-value is bigger than alpha, we do not reject H0. We do not reject H0. Okay? So if we do not reject H0 here, that means we do not support the other one. And now they said that if the true value of mu is 59, so now the true value, the actual value mu, the true value is mu equal 59, and that is the same thing as the null hypothesis. And we do not reject that, so that means we make a good decision, right? We make a correct decision because we do not reject H0, and in fact it is also equal to the value that we do not reject. So we make the correct decision. So the answer should be A, 22A. Okay, this is the last question for this video. A telecommunications company provided its cable TV subscribers with free access to a new channel for a month. Then it chose a sample of 550 viewers and then asked them whether they would be willing to pay an extra $10 per month to continue access to the channel. Now, a total of 25 replied that they would be willing to pay. The marketing director of the company claims that more than 5% of all of its subscribers would be willing to pay. Can you conclude that the director's claim is true? Use the alpha equals 0.05 level of significance. Now, this problem is the problem about proportion. They are given the sample size, and they said that a certain amount of the sample reply yes or no, right? So that this is the type of the proportion, not the mean, not the standard deviation or other things. And we know that we have the sample size of 550, and out of 550, only 25 subjects reply that they would be willing to pay, so x equals 25. And therefore, I can find the p hat, the point estimate, which is x over n, or 550 divided by 25, which is 22. Now we know that they claim more than 5%. 5% is 0.05. So more than 5%, that means the proportion bigger than 5%, 0.05, would be willing to pay. We know that anything that did not include the equality side, the equal side, we will treat that as the alternative hypothesis. And then therefore the null hypothesis is the proportion equal with the equality 0.05. So this is the hypothesis that we have to perform the testing to see if we should reject or fail to reject the null hypothesis. Now this is the proportion case. So go back to the notes here. We know that we have to check the requirement, make sure n p0 n q0 is bigger than 5, so that we can use a normal distribution as an approximation to the binomial distribution. We know that this is a random sample, simple random sample, and we also know that this is a binomial because they pay $10 or they don't pay $10. So the answer is yes or no, two outcomes. So this is a binomial. The last thing is we have to check for these two inequalities. So this value right here is the p0, the assumed value, right? P0. And therefore, I can check n p0. So n p0, n is 550, multiply 0.05, and then n q0, q0 is 1 minus p0. So 550 and 1 minus 0.05. So let's check these two values. And the two values here, they are all bigger than or equal to 5. So yes, we can use the normal z as an approximation to the binomial distribution. And therefore, our test statistic is z0 right here. So z0 is equal to the point estimate p hat minus p0 all over the square root of what? p0 q0 all over n. And we know that p hat, we found out to be 22, and your p0 right here, oops, this is a mistake right here. So I flip this one. The x should be 25. So I make a small little mistake right here. So x is 25 over 550, so 0.045. Right. So p hat 0.045 minus p0. P0 is 0.05 all over the square root of p0 is 0.05. q0 1 minus 0.05 all over n, and it's 550. And the answer should be minus 0.5 0.538. Now, we know that if you look at the alternative hypothesis, the arrow here is pointing to the right, so this is the right tail test. So we can draw the normal curve. The center is 0. This is minus 0.538. Minus 0.538, yes. So it should be around here, 38. Right. If this is the minus for the test statistic, there should be also a plus, right? Because this is the normal curve, so they are symmetric. There's a minus, there's a plus, and this is the right tail. So you are looking for the area to the right only, right? The right tail, not the left tail. So now the p-value, we are looking for the p-value. The p-value again is just the area of the right, and we can use the second distribution, and we can use this is the normal, so we normal CDF. The lower is 0.538, the upper all the way to the right, so 99999. A huge value 0 for mean, right? A center standard deviation is 1, and the p-value is 0.295. That is the p-value is 0.295, and your alpha is 0.05. So this is bigger than alpha, right? 0.05 only. So when the p-value is bigger than alpha, we do not reject. We do not reject H0. So we do not reject this one here. If we do not reject the H0, that means we don't support the other one, right? Because we did not reject the H0, so we won't support this one. That means we go back to the question. If we don't support the H1, that means can you conclude that the rector's claim is true? The answer is no, because he claimed that 5%, more than 5% of proportion is bigger than 0.05 of all of its subscribers would be willing to pay. But because we did not reject the null hypothesis, therefore we cross out. We did not reject this one, therefore we did not support this one, right? We cross out this one. Or the claim of more than 5%, we said no. So can you conclude that the director's claim is true? The answer is no, because this is the claim and we crossed out, so the answer is no. Okay, so that's the end of this video.